In the frozen realms of Siberia, astonishing phenomena unfold as methane trapped beneath melting permafrost finds its way to the surface, sometimes in an explosive depressurization. These methane explosions, a result of climate change and shifting geologies, spark curiosity about what lies beneath ice-covered landscapes. Imagine a world where, under layers of frost, explosive gases await release, creating an intricate web of potential devastation and beauty beneath the cold cap. Examining the icy containment, one wonders if isolated bubbles of methane could become trapped within pure ice as well, remaining dormant until ignited by a stray spark. Picture a pristine expanse of ice with each bubble reflecting light like a crystalline gem, hiding secrets of explosive potential. The very nature of these bubbles raises questions about their longevity and whether they could continue to build quantity indefinitely. Creating a massive methane bomb collected and restrained by the thick ice of, let's say, the Laurentide ice sheet in Pleistocene North America, the ideal conditions for such an event, a perfect storm, would require that pure methane remains untainted by other gases, allowing pressures to build within the ice. The generation of such massive quantities of methane require decomposition of organic material, normally limited by the ice. However, when ice recedes and vegetation is allowed to grow, conditions are primed for this encapsulated production of methane, if the ice then retakes its lost territory. We are seeing the results of this process in Greenland, where during the Holocene maximum, when Greenland lost much of its ice, the ice retreated and life advanced on the ice's lost territory for a time, roughly between 10,000 years ago and 5,000 years ago, after which the ice reclaimed its territory. Today, highly pressurized methane from the life of Greenland in the Holocene maximum is trying to force its way out, pushing fresh glacial water out with force. A similar scenario occurred during the infamous Younger Dryas period, which was preceded by the Bowling Alarod, a period of warmth and glacial retreat. Scientists know the methane was there and expect to see it reflected in core samples and the like. However, they are surprised that they do not see the methane spike in the record. But perhaps that is because it burned up in a cataclysmic explosion. Envision each bubble encapsulating enormous energy, nestled quietly, vulnerable yet elusive. Such pristine circumstances resemble a whimsical idea, but scientists are uncovering layers of complexity related to methane's behavior in ice. However, the ramifications of these methane bubbles extend beyond mere curiosity. A chain reaction ignited by a singular spark could unleash destruction on an unprecedented scale. Picture a vivid explosion, with the adjacent bubbles responding in unison, spiraling into chaos as a magnificent but deadly chain reaction unfolds. Would the explosive nature of this brief, chaotic display offer insight into our understanding of geological phenomena, or merely serve as a reminder of nature's unpredictable temperament? And what of mankind at this time? Could we have somehow contributed to such an event? The latent power is there ready to be tapped, simply requiring the combination of simultaneous depressurization, allowing the methane to oxygenate and the spark to ignite it. Could such an event be entirely terrestrial? A large volcanic eruption or forest fire dispersing ash and embers, reducing the albedo of the ice and melting it rapidly, causing major collapse while simultaneously providing the spark of ignition. Perhaps such a fire could be due to the activity of man as well. There is currently a very popular theory called the Younger Dryas impact hypothesis with scientific support. If such an event cannot occur without major upheaval from a comet strike, perhaps it could supplement the explosive power of such a strike, causing the threshold of the magnitude needed to cause the secondary impacts from the glacier ice impact hypothesis, proposed by Antonio Zamora, to be drastically reduced. In contemplating such events, one cannot dismiss the correlative traits shared between Greenland during the Holocene maximum and the Laurentide ice sheet during the advancement and retreat it is proven to have experienced. The interconnectedness of geological features across vast latitudes paints a picture that intertwines our planet's history with suspense and excitement. Whether these ideas hold weight or merely offer fertile ground for speculation, they fuel the imagination and encourage exploration of the enigmatic forces swirling beneath our feet, lying in wait beneath icy facades, eager to showcase world-altering revelations.